Okay, so I'm gonna start off with some slides to just sort of introduce you to things, and then I'm going to move into a tutorial notebook, which I hope you will all follow along on because, well, reasons. Okay, so Cactus, as hopefully you know by now, is a popular coding infrastructure that's been around since about 1996. It was designed to facilitate cooperation between researchers, and it's got an interoperable way to describe computations that take place on logical boxes. So within and within that framework, you can do unigrid, adaptive mesh, and multi-patch, and all kinds of things. Why was Cactus successful? I mean, you can't really know for sure because you can't scientifically study why something was successful, because you can't make a billion of them and see which ones failed. But I think it's for several reasons. So modularization. So the CS infrastructure code, the IO code, and the physics code in Cactus are all separate. I mean, almost any other science code that I come across that I've seen somebody written, those things are all mixed together, right? The time integrator is deeply integrated with the thing that calculates the right-hand side. And then there's a print statement in there too, usually, or some kind of write statement. And that's one of the things that Cactus encourages you to do, is to keep those kinds of things separate. Secondly, there's no central control to Cactus, right? It was designed to be decentralized so that you can just assemble your Thorns from anywhere. It's completely free and open source. Not all scientific codes are that way. More and more of them are, I assume. But I think that Cactus became sort of a standard way of doing things, and a lot of people who had funding got behind that standard way of doing things. And so it became something like NPI, right? There could have been 1,000 different ways to standardize on message passing, but NPI was the one that won. So I think there's some small NPI effect there into the reason Cactus became the way it did. Next, let's think about Nerpi Plus, which was developed to translate symbolic equations to working code. And it was used, and it can be used for generating Cactus Thorns. When I went to look at it, it was missing a few steps. It couldn't do the read-write declarations. It couldn't do the carpet driver, and there's a couple other small details. We're going to talk about some of those. Carpet is the current release driver for Cactus AMR. CarpetX is the next generation driver being built for Cactus AMR. So maybe that's in beta. I don't think anybody's officially called it that, but I mean, it's still under a lot of development. And both frameworks are potential targets for code generation. They have different boilerplate and loop structure. They use different time integrators as standard time integrators. Originally, Paul Walker, who was the guy who created Cactus and who's no longer in physics or computer science or anything academic, he went off to the business world. Originally, he wanted to take symbolic equations as input. He wanted you to put your differential equations, your boundary conditions, and then generate a complete code that ran on whatever. And I remember when he was talking about this and he was all excited, I was thinking, that's really kind of too ambitious. You're never going to get that done. And I think he must have realized that at some point, because obviously that's not what Cactus does. So, but the basic concept was sound. It was supposed to separate physics, numerical methods, hardware optimization, parallelism, all those sorts of things to keep them, distinct so that different people could work on them. And by and large, it worked. The problems came, of course, with some modern hardware. OpenMP started polluting things in there a little bit. And GPUs, well, we only have had those recently. So Paul was not able to realize his vision in 1996, but what about now? So there's a couple of things that are new since then. There's Python. I think I'd heard of it back around that time, but I didn't know what it was. Everybody just used Perl. And then there's Sympy, right, which is kind of like a free second-class version of Mathematica that we didn't have. C++ has become a lot more advanced, and it can take over the separation of concerns for things like, or partially do so for things like GPUs and loop parallelism. And then Amrex was built to help facilitate the creation of AMR frameworks. And so when I'm looking at this kind of thing, I'm kind of wondering if we're close to the time when we're ready to realize Paul's original vision. So we have Nerpi Plus Cactus. So for this tutorial, we're going to use a fork of the Nerpi Plus repo. We hope to merge it shortly, but we just didn't get it done before the workshop. The repo simplifies the creation of physics thorns for both Carpet and CarpetX. So in principle, you can change which one you're writing for by changing one line of code. It generates all the boilerplate for both frameworks. And so, and I would consider it sort of an alpha release. So this is an alpha release for a beta release of something. So keep that in mind. I would like your feedback on the way things work. All right. So that's sort of just a brief introduction to where this work fits into the landscape. Now, what I would like you to do is I would like you to all participate in the tutorial, or at least a large number of you, because I was given an hour and 40 minutes. And if you don't do the tutorial and the exercises, I don't think I'm going to use that much time. So, so I'm counting on people to try things and for me to have to answer a few questions. All right. So what we need to do in order to get to the tutorial is the standard way you do it with all these talks in this series. What we're going to do is we're going to come in through the schedule. You're going to go down to where my name is, and then you're going to click on the tutorial. And there's going to be some instructions here, and they're kind of the same instructions that you've gotten all along. You need to go to the ET 2022 uidaho.ncsa.illinois.edu website, and then you need to log in. And if you haven't created an account yet, your code is MC2. It's right there. And then you're going to get a notebook, and then you're going to get a notebook server. And when you come in to that notebook server, you're going to see this page. Okay, when you see that page, what you're going to do is you're going to select CarpetX tutorial Friday.
Steve, are you sure about that?
Yes, I'm sure about that. Why wouldn't I be?
Because one of the servers is for CPUs and the other for GPUs.
Yes, I want the one for GPUs.
Okay.
Because we're going to create a Thorn that runs on a GPU.
Of course. How silly of me.
It's taking a little while.
It's taking a little while to start up, but I suspect that there are other people who are getting started up too. So let's just give it a minute.
The server is allocating nodes and so on. I think at the moment 14 or 17 or so have been created.
I think it takes like four minutes or so to create this. Okay, so in any event, pretty soon now we're going to see a notebook, which, well, we're going to do two notebooks. So there's first notebook we're going to do is called Setup Cactus, and we're just going to run that one completely. And all that's going to do is that's going to insert a compiled Cactus into our home directories, because while this machine has a GPU and a CPU, they're like really old, really underpowered things. And if we wanted to actually compile Cactus, we'd have to start the tutorial tomorrow.
You know the name we're supposed to start on? It just loaded for me. Cactus.
Setup Cactus. And run Setup Cactus completely. You can just set, just go up to the top and say kernel run all, and it should be fine. Alternatively, you can hit Shift Enter in every one of the cells. There's not that many of them. There's 5. That's not that many, in my opinion.
Just stating facts.
Thank you.
It's not. Yeah, that one.
All right. So fortunately or unfortunately, I'm probably one of the last people in the room to get a machine.
Entertain us.
So after the setup Cactus notebook is finished, then you can start looking at the Nerpi tutorial notebook, which should have magically appeared in your home directory. It's really close. Look how far that bar has gone.
I got more and more nodes are on.
Yeah.
I like 0 out of 10, 0 out of 25, 0 out of 30.
Then they are available. Oh no, 0 or 32.
0 out of 32 nodes are available. Wait a minute.
They said do 0 out of 10 earlier.
Yeah, I'm.
Oh, I see. So it's allocating more. So it'll get to like 0 out of 40, and then I'll finally get one.
Yes, yes. It's allocating nodes. Apparently, so far it allocated 32. And if you judge the number of people, then you see how high it'll go.
That's interesting. We have 32 insufficient. Oh, NVIDIA comms. Okay.
Yeah, 1 per node.
Oh,
So I got a question. So when it comes to the GPU stuff,
Yes.
is it NVIDIA only?
No. So I've only run it on NVIDIA only, but my understanding, and Eric can correct me if I'm wrong, my understanding is the Amrex framework is capable of running on the Radeon GPUs, but I don't know that any of us have tried it.
That is correct. Both parts of your statement.
You timed out?
The 300 seconds.
Yeah, it does time out if it takes too long. I got 0 out of 34 now.
Almost got it.
The timing out should be fine because the nodes are still created. So if you log in again, it won't have to provision it again.
Anyway, even though this startup is a little slow, I think this Google Cloud framework is pretty cool. The other thing I can tell you is the notebook that the image that we're using to run this tutorial. After watching Matt's talk on Tuesday, was it?
Tuesday or Monday.
Tuesday.
Yeah, after watching Matt's talk, I wondered whether I could use this same image on a production machine and through Singularity.
So now, see, remembers most of it.
Successfully assigned. Look at that. All right. So anyway, I took this image and I was able to compile Cactus on Singularity on a machine we have at LSU called Deep Bayou. And I was able to run a GPU job within it. So that was kind of exciting. So, all right, I'm going to do the setup Cactus just to make sure I've got what I think I've got. All right, so I open this notebook. And this is the standard thing we have at the top of every one of our notebooks. So this is going to, this is going to be the complete source code as well as all .o files and all kinds of other artifacts created during compilation. And this will take another couple of minutes to run. And we get to watch this go by.
Is there a timeout we need to be worried about for Jupyter Hub? Like if we don't do something? Oh, it's a really nice.
Yeah, I don't expect that we'll hit it. I think the big hurdle was actually getting a server. And once you have a server, you shouldn't have any other problems.
Possibly.
I stayed at the 12 hours long.
Yeah, it's not. Oh, you're thinking of something like Binder where you leave
Yeah,
it inactive.
exactly.
Yeah, no, we don't really have that kind of issue.
Sweet.
Actually, we do. I think it is
We
13
do?
minutes.
It's 13. Oh, 13 minutes. Okay.
No, 30, half an hour.
30.
Get disconnected.
Okay. Well, I haven't encountered it before, so maybe that's a new feature. Look, I look
Yes.
up when I talk to Eric because his voice comes out of the ceiling.
Oh.
All right. Still running.
This may reveal my lack of computer knowledge, but what is it doing that says inflating?
It's coming out of a zip file, so it's what? That would be making it smaller. I don't know. What?
Deflate.
I didn't see no, there's extracting, not exflating. Extracting.
Yeah, it's going live so fast, maybe we didn't update the visuals, right?
All right, so now I should have everything I want, and now I'm just running the build. Now, the build step at this point really
Slow down,
shouldn't-
Steve. Slow down, Steve. None of the others is following you.
Okay, so what I've done is it's finished, opening up the zip ball, right? And now what we're gonna do is we're gonna call build GPU, we're gonna copy the Cactus Thorn list into our home directory so that we have the possibility of modifying it, which is important for this tutorial. And then I'm gonna call build GPU, which will just run make on Cactus, which really shouldn't really do anything. It should just, it should be a no-op. But we should see Cactus going through its motions of checking all the packages and Thorns. Everybody with me?
No,
Do you need help?
you need to wait. It's currently deleting the cactus source tree.
Yeah.
It takes
No,
a lot of time.
I'm counting on you to do this. Well, all you're doing, right? All you're doing is installing Cactus. And the installation is largely done for you.
I think the file server might be a bit slow because many people hitting the same NFS server.
Yeah, it is a bit slow, I think, but it seems fine. It's not like what happened last time or the time before that or whenever it was. When we all went to unzip our tar balls and we pretty much ended the tutorial. Okay, so I'm looking at the link step, which is, takes a little while because we are linking a bunch of things. But that should finish any moment. Yep, done. And now we're pretty much
Why don't
ready.
you ask for a show of hands? Who is done with installing
Who's
Cactus?
done? Who's still processing? Okay, we're about half of us are still processing. When you're done processing, when you're done with this notebook, what I'd like you to do is open this notebook, Nerpi Wave Toy IPyNB. I'm gonna give you a couple minutes to get there. Does anybody need help? Nobody needs help. Not right now. You can reserve the right for help later.
Yeah.
I'm sorry.
Yeah.
There's some chat? Okay.
I didn't even go to the board.
Okay, so it's just letting us know that we shouldn't worry about the number of nodes. Oh, and then something else came in. All right. How many people are done now? How many people are still running? Oh, wow, still a lot of people. Okay. So I'll take just a few more minutes to let you all get in. So for those of you who have your notebooks, well, you can open the second notebook while your other one is compiling. So you can open it up and look at it, but don't start running it yet because it won't. You need to make sure you have Cactus available. Actually, it's okay even if you start running it now because until we get to a certain step, it won't interfere. So let's get started on this second notebook. So let's everybody open Nerpi Wave Toy. So I've got two notebooks open right now, right? I've got Setup Cactus and I've got Nerpi Wave Toy. All right. So if everybody would like to open Nerpi Wave Toy. Excellent. If everyone would like to open up Nerpi Wave Toy, you can execute the first cell. This is the same boilerplate you've seen from other tutorials at this workshop, setting things up so that you have a nice bash interface so that you can do this CD command inline like this, setting up your scroll down and so on. Okay, so let's CD to our root directory. Now what we're going to do is we're going to fetch or update our new NRPy tutorial repo. Mine is already up to date. Yours is probably going to get checked out. So that's all that this little block of code does. And then we're going to CD into the NRPy tutorial directory. The next thing we're going to do is we're going to set our ET driver. Now I've set this to CarpetX, and I would like you to use CarpetX for this tutorial because CarpetX is what we have pre-installed, not regular Carpet. So even though this can in principle generate code for Carpet and you can try out looking at it, you can't compile and run it because the rest of the infrastructure just isn't there. So we're going to set that. And then what we're going to do is we're going to create a Thorn. Now, we're going to create an object called a Cactus Thorn. And so that's something that is inside the NRPy tutorial directory. And it's an object. And first we have an arrangement name and then a Thorn name. Okay, so my arrangement name is test1 and my Thorn name is NRPy wave toy. Yes.
What is the grid module that's required? It's a NRPy.
Yeah, it's a NRPy package, and we need to set. You may not approve of global variables, but we set a global variable there. And that is going to tell us which of the two infrastructures we want to use.
You usually download the tutorial and then you go in there and create generating notebooks in there. Like it's sort of kind of obvious, like you're loading NRPy modules, but here it's not obvious. You're just loading and right staying out of the way.
So after we create the Cactus Thorn, what we're going to do is we're going to create parameters, which we're going to need for our evolution. Now, what's going to happen here are two things. Okay, so first we're collecting the information that we need to generate a param.ccl Thorn, which you may remember seeing from Josef's tutorial or elsewhere, or from the recent tutorial by Gabrielle for, what was the name of your package? Juki. You recently saw the param file for Juki. So what we're doing is we're creating a parameter here. We're giving it its default vmin, vmax, docstring, and so on. But we're also getting back a Sympy object that we can use in equations, and which will feed through to the code generation. So we get a wave speed object and an x0 and a y0. Now, what I'm going to do here is I'm going to create a simple wave equation code. And for initial data, I'm going to want to create a hump somewhere in the center of the grid or maybe off to the side. You get to set where it goes with the x0 and y0 parameters. Okay, so that's what those three parameters do. Nothing terribly hard. Okay, so the next thing we're going to do is we're going to generate our grid functions. So we're going to take our principal evolution functions, which are going to be u and v, or uu and vv, right, for my wave equation. And then we're going to have the right-hand side variables, uu RHS and vv RHS. And in all of these things, we're declaring the centering to be CCC. So in CarpetX, you can have quantities that are either cell-centered or vertex-centered. And you can specify that for the x, y, and z directions. And so far in my testing and development of this, I've only really used CCC. It's one of the next things I want to do to put through the paces and start using, the vertex centering the way it's supposed to be used. This is a new feature, and if you put it there and generate a Carpet Thorn, it will be ignored because Carpet has no concept of this. Okay. So the other thing that this will do is it will get you grid functions x, y, and z. Well, it'll give you Sympy variables x, y, and z. And we had to do this in a special way because in Carpet, x, y, and z are grid functions. They exist everywhere on a grid, and you have to bring them in from another Thorn. In CarpetX, that's not really practical anymore because we've got this vertex centering, right? So you'd have to have x, y, z for centered. You have CCC, VCC, CVC, CCV versions, all these different versions you'd have to have. And it's just not worth it anymore. And that's just not the way it's done. So because we're getting X, Y, and Z in two different ways with these two drivers, in this NRPy Thorn, it's abstracted to just get X, Y, and Z, and you can just use those in equations. And the Thorn generation will take care of which one you want. The other thing is the way you name your variables tells you what the right-hand side is. So in CarpetX and Carpet, there are different ways to tell you which variable goes to which one goes with which. In this framework, it's just the name. Okay, if it's UU, then and it's UU and UU RHS is the one that goes with it. So if you just name your variables appropriately, the framework will figure it out. Yes.
So does the parameter interface allows for other types? Because I think you're
Yes.
assuming that they're all real.
It does. I think I made integers work. I haven't tested the other things yet. And I don't like to show you things I haven't
So
tested.
don't worry. I'm just wondering how far you got, because I don't remember that.
Yeah, no, I may even have gotten keywords working. I don't remember.
Right.
But I didn't keep them here because I didn't know what to do with them.
Also, vmin and vmax are mandatory arguments or not really?
I think they have defaults. So it'll be like, if you don't put them in, then you can just put any real number there.
Okay, cool. Yeah, because I'm thinking like booleans, sometimes we don't add anything.
Yeah. Okay, let me execute this cell. All right, so the next cell, we're going to create our symbolic derivative. So one of the ideas behind doing things with NRPy, right, is that we don't want to mix the way we implement derivatives with the way we implement our physics that use derivatives. When we want to implement our physics equations, we just want to put derivatives in there, and we want something else to figure that out for us. We want to separate those concerns. And so in NRPy, we have to declare our derivative variables. So the convention is that you have an underscore, a D, and as many capital Ds as the number of derivatives that you take. And you create it with this declare rank 2. This is going to declare a variable with the same name that's in quotes and present it to Sympy, and it's going to have it's going to be a symmetric variable, so you can interchange and get the same sign, interchange the indices and get the same sign. You don't need a symmetry if you've only got one derivative, so we don't have one there. Okay, and we're not using the single derivative yet. That's for an exercise at the bottom of the tutorial. Okay, and then I'm going to start my evolution equations. So I'm going to create an array of equations that I want to solve within this Thorn. And hopefully you can recognize the wave equation here. So we're going to say UU RHS equals VV, and VV RHS equals the wave speed squared times UU underscore DD plus UU underscore DD, where I put the 0 here for the X direction and the 1 here for the Y direction. Okay, so this is going to be a 2D wave equation. Are you all with me? All right. Okay, so now that was my evolution equations. Now for my initial value equations, I'm going to have something similar. So V is just going to be 0. And turns out I can't just put 0 in here because that will gum up the works. I have to say simplify 0. So I have to get a version of 0 that is a Sympy object that Sympy understands how to manipulate. Then I'm gonna, for UU, I'm using the magic function that I dreamed up, cosine K x minus x naught squared times cosine K times y minus y naught squared. I could have made K another parameter, I guess. I just made it a simplify of a constant, but I could have, used the parameter interface and made that another one. Okay. Yes. Yes.
The function calls for LHR. Why is it that on my screen I have right hand side.
Well, okay, so the wave equation, I probably should have written the wave equation here, but the wave equation, right, if you write it as 2 variables, that's how it looks. So I'm just going to use the whiteboard, and can I use the whiteboard? Yeah, please. All right, so du dt equals v, and dv dt equals c squared.
Okay. All right. Now I get it.
Okay.
Now I understood the function.
And by the way, it's not actually a function, it's a named tuple, which is why you see those equals things.
Yeah, right.
And named tuples are used throughout NRPy just to keep track of things for you.
Okay. All right, so the next thing that we're going to do is we're going to tell NRPy what we're going to pass it the finite difference order that we want to do. So I'm passing in a 4. Okay, and that means that that's the kind of finite difference it's going to generate when it goes to generate the code. Now, the next step is we're going to add the functions that we defined to the Thorn. So we're going to give the function a name, wave init and wave eval are the 2 names we're going to choose. For the body, we're going to take those arrays of equations, either the init equations or the eval equations. We're going to say, where this loop is going to operate. So in Cactus, we have the grid separated into the interior and the ghost zones. And so you can either say, interior ghost zones are everywhere, or interior boundary and everywhere, depending on which terms you like best. And for the initial equations, right, those are just functions of X. So I'm going to run those everywhere. I'm going to just fill in the whole grid, including the ghost zones, if there are any. And but when I do the evolution equations, those are going to use differentiation. And so that needs to be interior. Yes.
Someone asked a question online.
Someone asked a question online. How far out can we go in the integration order? Is n equal 4 the maximum? No, and in fact, one of the exercises is to increase it. I don't know that there is a maximum. I mean, there must be logically. I'm sure that if you put the differentiation order as 2 to the 32, that won't work. But
It'll probably crash.
what?
It'll probably crash. I mean,
It will probably crash, but
inversion.
But it should go. I mean, it's this is a symbolic manipulator that's being used here. It knows how to figure out the order, and you can basically put as big an order in there as you want. You want to go to 666th order, that might not crash. I don't know, but it's probably kind of impractical. Yes.
What you have to specify the CCC in the function calls?
Well, so it's not clear to me at this point how we know where you want that to, what you want that to be. Now, if all the grid variables have the same centering, then it would be the same as all of them. But suppose they have different centerings. Which of those do we want to iterate over? Or possibly we have a bunch of vertex centered variables and we want to integrate over the centers, right? And calculate something from them. So there isn't a way for me to know which one we want. So I have to let that be specified. We're trying to think about if there are any things that we should specifically disallow for correctness checking, but nothing like that has been implemented yet. Because we're not sure what we should disallow at the moment.
So if I want to look for here, for reasons that I cannot think of right now, I have to have the same function for every single CCC, BCC, CBC, or this kind of
No, they don't. They can all be whatever they want to be. The point is, you declare what the loop. This centering here is for the loop. Is for the loop you're going to do. Are you going to loop over centers, or are you going to loop over vertex?
If I want to look over all my.
I'm looping over the center. So if I had vertex centering, then I could then inside my loop I could say 0 plus index I and index I plus 1 and add them together, and I wouldn't go outside my bounds. Roland.
You want to explain where in the looping the difference between cell centers and the vertices of the cells comes.
So I'm not sure. What do you mean where it comes?
How does the loop over cells differ from the loop?
Oh, okay, I see. So what's going to happen, right, is you have a grid, say it looks like this, right? And if I have cell centers, they're here. So if I'm looping over everything and I have cell centers, I'm going over the dots. If I'm going over the vertexes, then if it's VVV, right, then I'm going to be going over these dots, right? And there's going to be more of them if it's vertex centered.
Okay, so say that I define a variable with the centers, but I'm looping over the vertices.
Right.
Will I get an error?
Depends on what you do inside the loop. Okay. So, you know, there's still some questions that we want to think about as to what can go on in those loops and how we want that to work. Question?
Steve, may I add something?
You certainly may.
In each loop, you can write only one particular kind of variable. So for example, if you want to write to cell-centered variables in a loop, then you can only write to cell-centered variables and not to vertex-centered, and it needs to be a cell-centered loop. So in principle, that is something that could be checked. You look at what is written inside the loop, and they must all have the same centering, and that's the centering of the loop.
Right. So in any event, okay, so that's how that goes. Now, at the moment, you have to specify whether you want interior or everywhere. But I think I can figure out which of those you want from what you pass in, right? If your equation contains a derivative or something equivalent to a derivative that goes outside of the current cell, right? Then you're going to want to do interior as opposed to everywhere. That's a future work thing. Okay, so let's execute that cell. Now, at this point, after you execute that cell, it's actually generated the derivatives for you and stored them in memory. Okay, so now I've got a package here called SafeWrite, which is just a small Python package that I made, and it's got one global variable called verbose. Now, the way this is going to generate files, it's going to only generate files if they've changed. So if you rerun your generator and you didn't change anything, or you only changed one file, you're not going to trigger a complete rebuild. So what SafeWrite is going to do is it's going to generate the file in memory. It's going to read the file. It's going to see if they're different. And if they're not different, it'll do nothing. But if you put this verbose flag on here, it will, instead of, if you change the file, it will generate a diff and print it on the screen. So that's sort of a debugging tool. But I'm going to set that, I'm just going to leave that at false. That's something you can play with if you have a mind to. All right. So now I'm going to set some variables. I'm going to get the home variable. I'm going to have the cactus home variable set to home cactus. I'm going to tell it which cactus sim, what the cactus sim is. So when you build cactus, you have to give it the name of a simulation, which by default is sim if you don't specify a name. And what we're going to do with this Thorn generation tool is we're going to go into the Thorn list, either the one, and that's going to be both the Thorn list that lives underneath the cactus configs directory and the one that you use to check out cactus with. It's going to write it into both places so that you have it available to you. Okay, and then I'm going to specify where my cactus Thorn list is, and then I'm going to click generate. And it writes a bunch of thorns. So it prints the word write every time it actually does write a file. So if it doesn't print that word, that means it didn't write it. And then it's going to append the thorns into the thorn lists for you. Okay, so it's gone over to your cactus configuration, which is in another directory, and it's written out the thorn, and it's written out all the stuff in it. I'm going to take a minute here. One of the things you can do inside these tutorial servers is you can open up a terminal. All right. Oh, that's not great, is it? How do I, well, okay, let's see let's see how readable it is. So we're going to go to Cactus, Arrangements, Test 1, Wave Toy, okay, and this is the thorn that it generated. So let's take a look at some of these things. We've got our interface.ccl, all right, and for each of these, so we're bringing in the loop device.hxx. We're setting the tags in the way that Cactus, the CarpetX wants. We're putting in the centering and so on. We're declaring the number of time levels and all that stuff. It figures it out. Look at our param file. There's the 3 parameters that we defined, generated in Cactus syntax. We have our schedule. We have and the schedule is going into ODE solvers. Oh, I forgot to point something out to you all. Let's go up and look at where we generated the equations again. So when I added the equations wave evolve, I told it the schedule bit, oh, I didn't do it right. Look at that. Okay, so this is what I did in my development that I didn't do here. I put just the word RHS here. And I encourage you to do that and try it. And if I do that and I run this again, you notice it didn't change anything. Yes.
Maybe here we go full screen and then increase the font size.
Yes. Okay, so what I did, right, is I went in here and I changed the schedule bin to just RHS. Now, RHS is a keyword that this framework knows, and it will generate that, and it will use that to either generate ODE solvers RHS if we're using CarpetX, or it will use mol calc RHS if we're using regular carpet. So that's a way that I can keep those things distinct and allow you to change one line of code to do your generation. Now, yes. Oh, there's a question in the chat. Schedule bin equal RHS. Yeah. Okay. Okay. So somebody answered the question. It looks like. Can we enable checkpointing of the state vector for the NRPy interface? So I have not tried to do checkpointing with CarpetX at all. I think that's a thing we're gonna work on at some point, but it doesn't work. It hasn't been tried yet. Are you raising your hand? No. Okay. All right. Okay. So I think this was supposed to be used. Do you have the same thing I have here? Because this is supposed to be in user local bin, right? You're good. That's what you're supposed to have. Apparently mine is old. Okay. Okay, so this is going to build Cactus, and this time we're actually going to do something. You see that the thorns that we created and some of the other ones that the Cactus framework generates are getting compiled, like the thorn bindings.c. And so now it's actually doing something. Now it's compiling this with NVCC so that we will have the capability of using CUDA. Oh, let me just go back to, come on, let me access the top of my screen.
Oh, you have to remove the auto scroll to bottom.
I have to do what now?
The auto scroll to bottom box is checked, you have to uncheck it.
No, I wanna go up here and get back to my terminal window.
Oh, weird.
So I guess I have to do this. Because it's underneath my controls. Okay, so if I go and I look in here, we will also see inside the source directory, we have our make code defined file, right, with the appropriate things added. We've got wave evol, right, which has got, and this has got our loops with the NRPy code and so forth, all expanded out with our finite differences and so on that we generated in nice, almost readable format. Yes, yeah, it's also got CarpetX index access. It needs that. So, all right, now I'm going to go back to my notebook, which requires me unmaximizing and maximizing. All right, so now this is run. We're going to make our parameter file. Now this parameter file is fairly small, simple, and straightforward. We're going to have, so this %% write file directive in the notebook is a way to create a file. It's going to create wave2d.par. Our active thorns are going to be wave toy NRPy, CarpetX, IOutil, and ODE solvers. So for our ODE solvers, I picked stability, preserving, run to cut at 3. I have the Cactus precinct mode set to mixed error, which we said we wanted. We have Cactus terminate is set to iteration. I defined 2 variables, block size and n blocks, which is determining how many iterations I'm going to do and how often I'm going to print out. I have CarpetX and Y periodic set to false. I thought I set those to true. Okay. We have some other things to control tile sizing. We've got verbose set to no, poison set to no. We set our grid size to be X, Y, and Z for an X, Y, and Z directions. Now this is a 2D simulation, but I still have to put a Z max and a Z min that are not the same. I can put a number of cells in the Z direction that is 1. That's just a requirement of CarpetX. And then I have my blocking factors, and it needs to be 1 in the Z direction because there's only 1 zone in that direction. Then for my ghost cells, I need 2 in the X direction and 2 in the Y direction. And I don't need ghost cells in the Z direction because this is a 2D simulation. I'm going to put my output inside a directory with the same name as the par file. I'm going to output every block size. Output mode, NP, I don't remember what that means. Eric?
It's a carpet thing. It means you specify the number, the output processors or so.
Output every 1 step, okay, and output PMD.
No. Outproc every process outputs.
Okay, and then it's
every nth process outputs, and here every process outputs data. That is the alternative would be to collect all the data in a single process before you output them.
Right, okay, I got it. Okay, so I assume you all heard that? Gabriel?
There is a question on the chat.
There's a question on the chat. So you are choosing an RC3 integrator now, but before you required a 4, is this consistent? So you just have a choice of ODE integrators. I had a 4th order derivative. No, that I wasn't paying any attention to that, to the consistency there. I was just putting in values for the purpose of testing. I could put an RK4. It's just, this is just what I happen to choose.
The 2 things are independent, right?
The two things are independent. But if you wanted a 4th order simulation, you know, why am I doing 4th order if I'm doing a 3rd order time integrator? I might have reasons, but yes, in principle, I might keep them the same if I was going for a consistent number. Okay, so now what we're going to do is we're going to run the code. So inside the cells, if you have curly brackets and something inside those cells, Python will evaluate that. So the cactus home variable I described before will get expanded here, and the cactus sim will get expanded there, and this will find out the current directory and identify the wave toy that way. So I run my code and voila, it worked. If I want to see what happened during the execution, I can uncheck this box and I can scroll up and I can see calling wave of all and all this other stuff that goes on. Yes?
What's the warning we get at the end?
I have no idea. There's some things you don't question. Apparently, Yax leaks an object. All right. I'm now going to CD into the directory where the output is. All right, and I listed the output of the directory, and you can see that in here we've got TSV files, which are tab separated values, and that's going to have mins and maxes of the grid variables, and we've got these .bps things which are open PMD, and you can tell that because they have the letter P in common. I don't know. But that's the way that works. And the BP files are actually directories with a couple of things inside them. So now what I'm going to do, since we don't have fully developed visualization tools for this, what I have is a sort of a hacked together Python script, which will use the OpenPMD library and plot something for us. And there's a couple little tricky bits to things that you do with OpenPMD. You have to call this flush thing to get the data to read in. I don't want to go over this in too much detail, but this is going to bring in our data. This is something that, as I say, this is something we need to have a real visualization tool for at some point. But at the moment, we've got 40 lines of Python which can read in the data for us. I'm going to remove any old PNGs that happen to be there in my directory, and then I'm going to call this script that I created, and it will generate PNGs. Now, if we had all coordinated everything, I could have used Gabrielle's movie tool to create a movie from these files. I'm just going to sort of call MPEG, FFmpeg myself. All right. So this generated all the files, and it shows min and max values as it did it. There is a bug somewhere that's showing us this 1.0e to the plus 277. This doesn't seem to be in the actual data. Because it doesn't spread throughout the grid for one thing. And also it doesn't show up in the TSV files. There's some kind of output artifact which we have to track down. But it's not too offensive when you look at the plots. So let's look at the files we generated. So we've got wave 00000.ping through wave 00019.ping. And we can look at a single image using this snippet of Python code. And there's our initial data. Now, on the left-hand side, you see those extraneous 1e to the 277 values. I've clipped those off when I generated the plot by specifying the vmin and vmax was -1 to 1. So it looks okay. And now what we're going to do is we're going to generate a movie. And we're just going to call FFmpeg. And it will generate a movie in GIF format. And now we can show the movie the same way we showed the single frame. And if you put that on the wall screen in your office, it will drive you insane. You have to like scroll away from it because may cause seizures. Okay, so the other thing that I'm going to do in here is I'm going to read in this TSV file and split everything out by tabs, collect the values, and print the min maxes for things. And that's the script to do it. And we run the script, and it shows you what the min and maximums are for UGF, and there's no 1e to the 277th in there. So there's something that's going funny with the OpenPMD output that we have to track down at some point. We have more questions in the chat. All right. Okay. So well, I shouldn't look away. What is the blocking factor x8? So this is a CarpetX parameter that's going to control parallelization and such. You want to comment, Eric?
Yes, I do. I believe it influences mesh refinement. When you flag a cell for refinement, it's not going to refine only one cell, but multiple cells for efficiency. And I believe it means it chooses blocks of that size that are either completely refined or not. So if any cell within an 8x8 block need refinement, the whole block is refined.
Okay, thanks, Eric. This code did not use, this code did use GPUs, but it did not use AMR. All right, any questions on this? We've all run a code. So you've all built a code in CarpetX and run it on a GPU. Think of how amazing that is. But try and feel amazed. All right.
You change it to it, you press buttons.
So, all right. So now I've got some exercises for you. And there's 3 of them, and they're not that, hopefully not that hard. First one is to change the finite difference order. So I put a 4 in there. I'd like you all to go back, scroll up, put a 6 in and rerun the cells and tell me what happens.
Rerun all of them.
Yeah, you run all of them after that, essentially.
Should I fix the bug first before I run?
There is, something will go wrong.
I know what's gonna go wrong.
Well, let it go wrong.
There was a way to fix it.
I already know how to fix it. Not even running.
There is a,
Credit, fix it.
Okay,
No, fixing it is fine, there was a way just so that it wouldn't cause an error.
that's all I'm saying.
Yeah. Like, I get that.
well, did you run it without fixing it?
Because I completely forgot that would be a problem.
Well, it's easy to forget that kind of thing.
Yeah.
What is preset mode mixed error mean?
This is something that we would develop for pre-sync, so that's checking the reads and writes and causing errors if you get something wrong.
So mixed means you mixed it up?
No, it means it's using a mixture of sync statements and pre-sync checking. There are no good names for anything. Every name you pick will confuse somebody. Okay, so has everybody seen the error yet? All right.
Oh, it's not done yet.
Doing HDF5 stuff, is that necessary, given that we're not outputting to HDF5?
The Thorn is probably just compiled in there. No, it's not necessary.
We're only loading for the Thorn.
Yeah, I could have trimmed this.
Yay,
So
okay.
look, this tutorial, that Cactus installation isn't just for this tutorial.
Yeah.
It's for all the CarpetX tutorials. And none of them use HDF5, so.
It says there's no directory.
Says there's no directory.
Yeah, that's what else. There's not one. I'm pretty sure that is easier having before than. Oh, it's not right.
Oh.
I don't know why that happened to me too. It said I couldn't find any of the PNG. Yeah, it was a series of errors, you know, but to be, yeah, that is good. But my bottom.
Yeah.
At one of them. Yeah.
All right.
Super stop.
So you should have, so how many people have seen the error? Yeah, so when you go to run the code, it generates an error and lets you know that, hey, you did something wrong. Right, so now you know, and it even tells you what you did wrong, so you know what to go back and fix.
So I have a question just about reading the output file. So I found where it's outputting the data, but I don't know at the command line how to access it when it's all in binary form.
Right, there is an OpenPMD ls function that you can use that will tell you some of the information in that file.
Yeah, cool.
But otherwise you need a Python script of some kind to see what's in there.
I just want to cat it.
Well, it's not an ASCII file. You can't cat an HDF5 file either.
I could write it.
Yeah, no, there's OpenPMD ls, you know, that we will probably at some point develop utilities that are accustomed to what we want to see from those files. I'm not sure. Okay, so if you go and you look at, let me go back to the source code. Yes, just a minute. So the point is, let's go back and look at the source code. So in wave of all, at the top, I have if n goes zones less than 2 CCTK error. So you notice that code is inserted at the top there where it's checking. Now, if you look inside the loop that we're generating, the loop is this, it's grid.loop int device. So it's C++ code generating a loop. And then inside there, we've got a C++ lambda function, which starts with this symbol here, right? So this is the beginning. This is the declaration of the lambda function, and this curly bracket is the beginning of the body of the lambda function. The lambda function takes an argument called pointDesc, which is the thing that CarpetX uses to tell you what index you're at and what X, Y, and Z are, and so on. Now, if you look at the code that's here, what this is doing, let's look at this line here. So this is UUGF P dot I. P dot I is the current point that we're iterating over. So that capital I is a vector. Can you see it? So what happens is that P dot I is an IJK. It's a vector. And what I'm doing here, when I add this DI1, that's plus 2 times 0, 1, 0, right? So what we're doing is we're creating an index, and that index goes outside of my current point into the ghost zones potentially if I'm on one of the edges, right? And if I don't have enough of those ghost zones, potentially something can go very wrong. I could get a seg fault or whatever CUDA does.
Nice. There we go.
Does affect something. That does not.
Just one octave. Anyway, so does that clarify why we need that ghost zone thing? So we're indexing outside of the current point, and when we're on the edge of the loop, that's going to go outside of the interior. Now, if I've only got 2 ghost zones and I try to index 3 outside of it, that's going to be bad, trademark.
Right.
What?
Oh, like it has to be.
Yeah, it's just an index out of bounds. It's trying to prevent an index out of bounds error, right? Because the finite difference stencil is going to go outside the current point. And if it goes too far outside, we won't have any ghost zones, and we don't have enough ghost zones to cover it, then there's an error, right? If it were running on the CPU, that would be a seg fault.
But if it went, like if you put 4 instead of 3, would it just not use, like it wouldn't?
Yeah, you can put 10 ghost zones there, and that would be crazy, but you wouldn't get an error.
A couple questions. First off, so looking at the visualization, it looks like there's something centered at 0.5 and 0.5. I thought we had set our center to be 0, or is it just that function I'm missing? Why?
Well, I thought it was centered at 0, 0. I mean, the grid, it goes from -1 to 1, or -10 to 10.
Right. Yeah, the grid does, and so we're just plotting a subset of that in that plot because it's the plot labels are from 0 to 1.
Oh, that's because I'm not getting the actual X coordinate.
Oh, okay. So you're just not plotting.
I'm not plotting the real X
Yeah,
coordinate.
so that leads to a follow-up question. That is, how do you handle the outer bounds?
At the moment, it should be periodic boundary conditions. I mean, it said periodic false, which confused me because I thought I was running with periodic, but it looks like somehow it's. So I'm not doing anything at the boundaries.
Maybe that's why it's giving you those.
Yeah, look, well, we could go back and set those to true and see if that fixes anything.
Did you see in the plot that there's in the visualization that there are some?
Yeah, I talked about that.
Oh, okay. Yeah. I was thinking maybe that's.
No, I don't know what that is because, as I said, that's not in the TSV files. So it seems to be an artifact of the OpenPMD. What's that?
Maybe you're including the ghosts in DSP files.
It could be. I haven't dug into that and figured out what the cause is.
I think in Carpet there was an option to either include ghosts in the output or not. So maybe there's some initial hours or something.
Let's try doing this, by the way.
That's part of that, we're looking at the point 2 something, so that shouldn't move those. If the ghost zones would be like 0, 1, like that.
Yeah.
What?
Yeah, but it looked like it was, it looked like it belongs to the interior.
Yeah.
All right. So in any event, I mean, this is, as I told you, this is very early work. I'd like to get more people to hammer on it and request features and so on. But I thought it would be nice to show you. Another thing that you can try is you can go back and change that CarpetX to Carpet. Your code won't compile, but you can go and look at what it does differently. So if I go, let me just do that quickly. And just take off the X. Oh, I shouldn't have run that again. Okay. All right. I may have not got what I shouldn't have run that. Hold on. Let me go back and look. Oh, I've already done. Now it didn't regenerate. I have an error in there. I'm sorry. I thought that would work. I could swear I did this beforehand, but when you do set it up, hold on. I can do the following. So that shell script calls all the same sort of commands that we've just been doing. And this is going to actually send it to a real Cactus.
Okay, question line, wait.
I'm sorry, what?
There's a question line, wait.
Yes, question. Oh, there's a question in the chat.
I can't even see them.
In which part of the notebook would we specify how and what to write to the regrid error function for CarpetX Thorns? So I guess that would be when you declare your grid variables where I did the UU and GG, you would create a variable there, and it would be of type. I have to remember now. I think external. So you notice that there's aux and aux eval as types of the grid functions. I think it has to be type external, and then you have to say module equal CarpetX. So that would get you the CarpetX regrid function. I have not tried to do mesh refinement with this thing yet. That's one of my next things on my list. Let me just kill this because I don't really want to run it. And that's what this is going to do. So this is looking at a Cactus installation that I have here, right? And all right, and here you see something totally different from what you saw before, right? So instead of these lambda functions, you see regular loops. If you're going to see CCTK for I2 in less than CCTK.LSH2 and so on. It's a standard carpet loop that you might have written if you were following along with Josef's tutorial. And if you look at the indexing that's done here, it's not using those vectors anymore. It's using I0, I1, and I2, right? Expanded out for you. And if you look also in this source directory, you will see register.cc, which will register the mol variables so that mol will work. I don't know what I messed up in the notebook to make that not work, but that's the way it should look. And if I look into interface.ccl, you'll notice that I have the mol register evolved function imported into that file. And there's no centerings on the declaration. So it changes all those things for you. It understands both frameworks.
Have you thought about dividing these up into the eval and aux groups or something like that, or creating groups of grid functions instead of individual? I know that's what MLBSSN likes to do.
Yeah, I know that the Mathematica scripts prefer to always generate them one at a time. It's easiest to generate them one at a time, but I mean, you know, if there's something to be gained by doing it a different way, I'm certainly all for it.
Probably the precinct works just fine.
Oh, and let me just, in case I don't think I showed you, I don't think I talked about this, but notice that the reads and writes are generated there. And Cactus needs storage declarations, and those are there. One of the things I tripped over when writing this is a weird behavior of Python where sets are non-deterministic. And I was, you know, I had my code in there that was only going to regenerate my source files if they weren't changed. But because of this non-deterministic behavior of sets, it was changing every time I generated it, even if nothing was different, right? These things would just come out in different orders for no reason. And so I had to sort them.
Yeah, it's just the weirdness.
Well, every language has some weirdnesses and some bugs, and you know.
If I'm not wrong, from 3.8, they're guaranteed to be in order of insertion.
Yeah, well, I don't care what order they're in, just as long as it doesn't change every time I run the code.
Maybe sort them alphabetically or so. Order of insertion is also annoying that you could produce a different Cactus code if you rearrange the lines.
Yeah, but in any event, it's sorted now. It just uses the default sorting for the names. All right. So there's two other exercises, and I will take questions if we have any. And I've still got 32 minutes. See, yes.
In the cell where we define the right side.
Yeah.
You had like 0, 0, 1, 1. Derivatives, where those come from? Or how do you know?
Well, it's X, Y, Z. So 0.
And then why, like, why is it, like, why is that here?
So we're taking it's x squared. So it's the wave equation. You've got the x squared plus dy squared.
Did you, if you write it as I, because that's probably. So
You see what I mean? So this is the Laplacian, right? It's 2x derivatives. 0, 0 is 2x derivatives. 1, 1 is 2y derivatives.
If you unwrap the variable name itself, UU, you know, UU underscore little d, capital D, capital D. So the capital D denotes that there is a down index. So think about Einstein notation. Right? So down index D, down index is sort of 2 there. It's kind of like charade. Two indices, okay, 2. DD means 2. And it's going to be an interesting. 0 is the first one, 0 is the second one.
Now, there's one other important thing I have to bring up. One other important thing I have to bring up with regard to this, and that is I need a graduate student. If you are capable of working on Python or CarpetX and those kind of things sound interesting to you, I'd like to get an application. Yes. Okay.
Well, actually,
I'm sorry.
we have well,
you're mixing different time.
Oh, you want to get an underscore P variable? I haven't even thought about that. But I mean, at some point, see, part of the thing is I want to start to get some Thorns working and then to start figuring out what kind of functionality we need, what kind of stuff can even fit in this framework, right? Do we want to write flux calculations inside Python loops like this and generate code, or does that not make sense? These are things I want to figure out, and I haven't thought about using past time levels inside a loop yet. Yes, Gabriel.
What are your thoughts about how you will use conditionals in your generated form?
So what kind of conditional do you have in mind?
I don't know. Sometimes it's useful to background first control. Maybe if I'm using the set parameters, substitute is not working formulas, or I want to activate or some smoothing, or I don't know. There's
Yeah.
It's change a little bit the equations to ensure better.
Right, so, so something that's that much of a change, I'd have to think about it, like, we could have something that does like a question mark operator, but you want something a little bigger than that.
Yeah, but I don't know, I'm thinking, sometimes it's, especially for to puncture, how to do there around to puncture, depending on the parameters I provide. Way. So this is not something I would do at the level of point generation, because I want to do it on time.
Right. So probably what you've got is you've got maybe different different functions that go in the schedule, and then maybe the schedule has some kind of if statement to decide which of them to run, something of that nature. And there might be a syntax that covers that. I'm not sure. Yeah, I'm sure there are some things that aren't going to work in this framework, right? And there might be things that work partially, right? So it may be that you want something complicated done with the schedule, and so you're just going to leave that out. This is going to be a work in progress until we figure out those use cases. Roland.
So I guess I was going to ask about the if statements and schedule as well, but you already answered that.
Yeah.
Do you currently have the ability to specify which group to schedule the function? So
Yeah, you can specify where it's scheduled. It's when you go to define the function, you specify the scheduling group. So I put and RHS is a magic one that can expand to either ODE solvers or Mal, Calc, or RHS. Yeah, it just takes a string and it will put that string into the schedule.
you put before and after statements.
Yeah, you can put a before and after in there.
I can abuse that string.
You can abuse that string.
Oh. I can do everything.
You can do everything then. Yes,
I have an unchecked string.
you have an unchecked string. It actually checks for capital RHS as with word boundaries. So the remainder of the time, as I said, are for those two small exercises or whatever other poking around you want to do. Ideally, your output should look different when you change those things.
Yes, yes, it does.
Oh, is that?
It is, it doesn't have to be.
Well, I didn't show you what happens when I do the exercises.
Well, I like to be a screen.
Oh, okay.
Oh, you probably had one up with X and Y. That's a little quick answer to the question too. Oh, you know how you can do the differentiation with respect to one, is you do one zero instead.
So, yes, X is 0.
So you need to do zero, yeah.
So, you know, I really.
Yeah, that's step 2, step 3. This is step 3. I understand. Like, I mean, it looks cool. It doesn't look like a video man.
Well, one of you did something different than the other.
Yeah.
Let me see what you got.
You're convinced.
Oh, maybe you did both of the exercises.
Oh, I did both at once, yeah. Yeah, you did both at once, but he did both at once too. Okay. Yeah, the background of this. He had experience.
That looks like what I would expect.
It's beautiful there.
He's doing something else.
Yeah, look, that's the same here. Yeah. Okay, so what did you do?
It's also going to trigger seizures.
Well, not that.
I find it upsetting to look at it for too long.
First one, yeah. First one to like 2.
Yeah. And try to work with that on the screen on the front of the room. You can't. Your eye just keeps getting going up.
Yeah.
This is good. People are having fun.
Yeah, I love it.
You don't know what we're doing.
Yeah.
Yes, you do. It's wait. You know the wait.
I sort of. Yes, it's just like. Well,
So one of the things I want to do next with it is I want to do a Boost-Nesk equation.
I don't know if I'm familiar with that.
Boost-Nesk equation is a water wave equation. It's a 2D version of, that you use for ocean waves. It's a moderately complicated, I mean, not by relativity standards, but it's a reasonably complicated set of expressions that you derive by making approximations about what happens in the z direction and forward equations. It's 2D, yes. I might. I don't have it there. It's okay.
So I'll say that if I were doing exercises, or if I were look at the bottom, first of all, I would sort out the exact solution.
Yeah.
And then I just demonstrate. And that
If you were making like a Nerpi test notebook.
Exactly. With this,
Yeah.
I would have two power files, one for low range, one for high range. No, they actually think it is emergence.
Yeah, it makes sense.
It's really interesting because the next order.
Right.
And you're using the difference order. And also, it's very curious to see how the changes.
Right across the
The outer boundary.
Yeah.
The outer boundary is I bet you're gonna see a non-convergence creep in over time.
It could be.
It's very.
I mean, I think even though that thing was set to false, I think it was doing periodic, and if it was periodic boundary conditions, it should be okay. Because nothing bad should creep in if I have periodic. If I'm trying to do some kind of outgoing thing, then yeah, I'm sure that'll mess up.
Where do you set the final time?
It or last. Yeah. Right. So that's because I don't want to output every step, because if I output every step, then it just takes too long to generate the movie.
So here was, now I understand the question better. Maybe I'm the only one who didn't. So when you declare U and VB, how many time levels do they have?
It depends on whether it's Carpet or CarpetX. So Carpet is going to need 3 time levels, and CarpetX needs 1.
So now here's the question: how do you take derivatives of the different time levels? Because you have to declare them as Nerpi grid functions, principally, to be able to take derivatives. That was the very specific question.
So by default, Cactus has these _p things, which represent previous time step.
I know.
And if I put if I made the other time level available, right, then I could access it, and I could access the variable with the _p name. That might be the way to do it.
That's correct, but the problem is to take derivatives of that in Nerpi, you have to declare them as grid functions. Then
Right.
you declare new grid functions that are not supposed to be new grid functions, they're just time levels. So
Yeah, we might have to tweak. Yeah, we might have to tweak some piece of code.
Yeah.
We might have to tweak something somewhere.
Yeah, but it's just,
That's just a small.
I think it's a specific thing. I never had to do that first. I take
Right.
derivatives, speak of derivatives of different times.
Yeah.
I was proud of myself when I got rid of the _GFs at the end. So
Did you revert? You were equating back to the way
no, what's that?
I did, that's why I was. Yeah.
NB is Mathematica.
Versus low bar is not enough.
Oh, yeah, we don't have those bars.
Oh, yeah.
So you take multiply these.
I don't know what that is. Anyway, I've got a Mathematica notebook where I walk through the derivation of the Bouchier equation. Yeah. What? No. I was just trying to understand the steps.
Just do y minus y naught.
There was, you know, a student of Ian Hinders who had cooked up. There was a female student who had cooked up some variant of the Boussinesque equations for studying fluid flows on neutron stars. I don't know where that went, but I thought that was interesting. But you would use Boussinesque equations for modeling tsunamis and such.
Yeah.
Oh. Is there any chance that we might need to define the spatial derivatives as Hawk's grid functions? I don't think that you need to do that. The spatial derivatives are just Sympy objects. You could create a grid function and you could store the derivative in there. But the derivative, when you see that derivative, that just expands out. If you look at, let's look again at wave of all.c. So if we look at wave of all.c,
I mean, for it looks like you just.
so you see all these variables here, p dot I plus two times di and so on, right? All these different pieces. Then you see uu dd 0, 0. Here's the derivative, right? It's being stored as a scalar within the loop, right? It doesn't need to be a grid function for whoever asked that.
You're doing the K.
Steve?
Did that answer your question, Li Wei? I hope it did.
Steve, can you hear me?
I had
Hello,
a
Steve?
CarpetX question.
Yeah.
So these fancy loop macros that are used, GPU, CPU compatible, are they also in the CPU case doing loop tiling?
Yes, it's because the loop tiling is actually done by Amrex.
So basically, this is all just saying, okay, Amrex, have at it. And there's
Yes.
some complicated.
Yes, and yeah, there's a little flag that gets passed to Amrex to tell it whether to do tiling or not. And usually the way they turn it, if you get the GPU, then you turn off the tiling.
I see. Is the reason why the carpet one didn't run because you tried running the GPU?
I'm sorry, ask that again.
So you were, if I remember right, then you were trying to generate the carpet.
Oh, yeah, no, the problem, I messed something else up in the notebook and I'm not sure what it is. It didn't generate the carpet code there. Right, so that's why I went to DeepBayou because I knew I had this set up correct there. Li Wei, you there? Did I answer your question?
Steve, can you hear me?
So the finite difference is actually kind of expensive, but I mean, we don't need to store it. We're just sort of generating it as we use it. We could store it, right? If you were going to use it multiple times, like if I was going to use that same derivative in a bunch of places. Eric, no, I do not hear you. Are you trying to talk?
Yes, I am.
Ah, there you are.
There I am.
Voice-
Very good.
The voice from on high is back.
Okay, maybe you couldn't hear leeway either.
What's that?
Maybe you couldn't hear leeway either.
No, I couldn't hear Li Wei. He was typing in the chat though.
Yes, yes. You ask another question.
Well, I thought I answered it. So he asked if it was if it was stored in a scalar because it's cheap, and I say it's not cheap. Calculating finite derivative is not cheap. It's potentially going to mess up your cache and everything. But we're only using it once, so there's nothing to be gained by saving it off in a function
In this.
Okay.
scenario.
in this scenario.
Yeah,
But yeah,
actually,
it could be. Go ahead, Derek.
there's a feature request I have, and that is to have a temporary array. It's not a grid function, but just a temporary tile and writing something in there.
Well, regardless, the point is we want to, the people who are writing physics thorns shouldn't have to be implementing the derivative. And so that's one of the, however, you know, if we come up with some fancier way to do it, we'll just switch it to using that. But the people writing the physics thorns shouldn't need to care.
Okay.
That. Yes.
In the like GIF thing and the image too, what are are those the ghosts?
You mean the noise at the edge?
Yeah.
That is, I don't know what that is. As I said, that I think that's some kind of bug that's happening when we're doing the output, and I haven't tracked it down yet.
Is that is it related to the ghost?
Yeah, no, it looks like it's in the ghost zones, but not all of them, and it's just sort of random looking. I'm not sure. It looks like uninitialized data.
Oh, is it kind of weird when you define zero?
Yes, because when Sympy is a symbolic manipulator, right? And it wants everything that it's working with to be a Sympy symbol, right? And that includes numbers. So it just, you know, all the symbols that it has fit into data structures, and they want to have common methods on those data structures to introspect them as they're doing simplifying expressions and whatever. And zero just doesn't have those things. Right, so, but you can just say simplify and give it a constant, and it creates a Sympy object to wrap that zero. That really confused me when I first stumbled across it. I thought I could just use zero.
Yeah.
But I kind of feel like that's worth knowing. I mean, it's part of your introduction to the world of Sympy.
The one that's kind of clear or like empty on the right.
Yeah, the one. You mean UU equal VV?
No.
Oh, you mean the image?
Yeah.
So,
It's just that turquoise. So I'm saying is that just kind of like an empty uninitialized.
hold on. Mouse is so hard to use sometimes.
If it doesn't spread, then it's probably because the way when you put something on there, it's going to propagate. So if it's spread around, then I don't think it's something that's happening in the raw data. So my guess is it's a visualization artifact, which can happen if there's a messed up setting or issue with that button. That's my, or even if it's MPEG, when it tries to encode this, it's trying to.
It's not FFmpeg though. We know it's.
You can see the first frame. It's string.
First frame.
First frame as the same should, so it's not.
String.
All right. Any other questions, thoughts? I thought I got all those.
So I just added a new one.
Is there a way to see the C code after the preprocessor in CarpetX? Yeah, you can. So that grid.loop is not a macro.
Okay. I said in my next comment, maybe preprocessor is the right term. So.
No, it isn't the right term. It's not a macro. So if you look at there's a loop.hxx, I think it is. If you look in loop.hxx, you can find the C++ code that implements the loops. Yes,
10 minutes.
And Eric, again, and we got the full one is CarpetX/source/loop.hxx.
Because these looping things are deep into the guts of CarpetX.
Yes, they are.
So they're definitely, they have an API to tell you what they do. Trust.
Yeah, you have to.
I mean, I can see some actual code. Famous last words, right?
Darn it, we didn't hide it well enough.
I can just ask them how the bit testing works.
How the what?
How the people hiding actually produce anything.
All right, anything else? Anyone want to eat a stale bagel? It's now's your chance.
There you go.
When they do delivering food.
Oh, do they?
Yeah, real brands.
Well, are there any other questions before we conclude our tutorial? Feel free to try out your own interesting functions for your initial data. You may find some interesting looking results.
And I don't know how long these machines are going to stay around. If you have any interest in saving your work, you should probably download it, but you may not.
Fair enough. All right, well, thanks again, everyone.